Yeah, Nidhi, please proceed. I started the recording now.
Okay. So, a very good morning, good evening, good afternoon to all of you who are joining from different time zones. So, I thank you for joining today. So, this is IEEE Student Branch IIT Kharagpur, and the webinar is on edge computing and extension to cloud computing. And the speaker of the day today, we have with us Mr. Ramneek Kalra. He is IEEE Impact Creator, a professional development coordinator at IEEE Delhi Young Professionals AG. So let's have a brief introduction about our speaker. So Ramneek is a computer science engineer and a proactive volunteer at numerous organizations, namely IEEE Youth for Sustainability, Atal Innovation Mission, which is a Niti Aayog Government of India project, Human Circle Young India Challenge. He is an IEEE young professional volunteer. He had volunteered and contributed as mentor to 4 teams in IEEE Extreme Programming Contest 14.0, chair of technical committee at IEEE WIE ILS 2020, co-chair of IEEE Data Science Bootcamp 1.0 under IEEE SSIT Madras section chapter, project development committee member at IEEE Smart Village US, advisor of Innovation Challenge track at IEEE YESISP 1 to 2020. Web developer at TEDx, AIA, CTR, Delhi, India, and chairperson of Webmaster of IEEE HMR Institute of Technology and Management, New Delhi, India. So you see, we have, he is associated with too many things from IEEE, and he is successful at each one of them. So with the curiosity to learn new things, he had deep dive into the research world as well. His research interests include edge computing and emerging technologies. He has published around 15 plus research papers in IEEE sponsored conferences, Elsevier and Springer journals, and he holds 1 patent, which was the motivation from his 3rd year research project. So Ramneek, thank you for joining us today. And I would like to continue. You can continue. Thank you.
Yeah, thank you so much, Nidhi, for that elaborative introduction. And thank you so much to IEEE IIT Kharagpur student branch. It's always great to connect through numerous student branches across the world and sharing knowledge, learning from each other. And during the session, guys, please feel free to come on the camera. Okay, it's totally fine. I know we are working from home. I won't judge, or anyone won't judge from your background what's going on. So it's fine. Okay, let's move ahead and let me share my screen. Yeah, 1 second. Perfect. Nidhi, can you please confirm if the slides are perfect?
Yes, they are visible. The slide is
Okay,
visible.
great. Thank you. Yeah. Okay, good morning, good afternoon, good evening. Depending upon your time zone, you have joined us because IEEE is all about diversity and inclusiveness. So we always welcome from other countries to each and every event because it's pandemic going on. I would say it's a fortunate and a lucky moment for IEEE people because we are going to connect with numerous borderless activities. So as Nidhi mentioned, today we are going to get a brief overview about edge computing and extension to cloud computing. Due to the resistance which I saw from the stats of the Google form, we have maximum percent of BTech bachelor students on the call. So I will be covering the basic concept of it so that you can just explore yourself after the session and you can research more on your own. Moving ahead, what we will be discussing about cloud computing, what is actually the thing in Internet of Things, and introduction to edge computing. Why edge computing? If we have already a cloud computing structure in the market, what are the different use cases of edge computing? What are the differences between edge and the fog computing? That's one of the great, I would say, confusion many of the researchers who are right now working in researching in edge computing, they are having it. And when I started this journey of edge computing in my 3rd year, it was around 2017 when I was in my 3rd year of BTech. And then I came to know when I was doing research assistantship under one of the professors in Delhi. Then we will get to know about the cutting edge technology, like the coming, what are like 5G is coming up in the market. AI is not yet deployed onto the edge. So we will be learning about some of the use cases there and how to get started in edge computing as a new starter, like because I learned edge computing like from the 1st year I was into IoT, Java development, software development, and all the stuff. When I joined research assistantship in 3rd year, so I was like, oh, the whole things what I was doing, IoT, cloud, and all those stuff, these all things integrate and comes with the edge computing model. So that was really surprising to know. And then we will be discussing what are the different available simulator tools. Sorry about that. Due to some issue in my laptop, I can't have the live simulation session. I was going to give a live demonstration on Cisco Packet Tracer. Hope you guys are aware about it. Cisco Packet Tracer is an open source tool by Cisco, which is specifically used by the Cisco employees for building the architecture of their model, of their data center and of their, I would say, network architecture. And in the last, let's connect and let's have an interactive QA and so that we can learn from each other. See, my attitude of conducting a webinar is not like I will speak. First of all, I will ask you, then I will speak because I want to learn from all of you guys also on the call. That's my intention of doing a webinar. Okay, so I hope many of you are aware about cloud computing, but let me give you an overview. So cloud computing is kind of a pay-as-you-go model. Can anyone please tell me in the chat window what are the different examples of cloud computing? I am on the chat window. As I mentioned, please feel free to communicate with me during the session onto the chat window. I will be really delighted to see your interactivity and engagement. Any use case of cloud computing? Any example or any use case that you use daily? It would be really sad that if you can't even bring the platform name which we are right now today on. Yeah, Google Sheet. Yeah, great. Thank you so much. It's a service rent model, renting compute storage. Great. Gmail. Yeah, Gmail is also one of the great service we are using on the basis of cloud computing. Google Photos. Okay. Okay, let's take all the Google products. What about next? Other than Google products. Yeah. Host, Android or Apple apps. Okay. Thank you so much. What about others? I guess we have a number of volunteers. Let me see how many volunteers. 26 members on the call, including me. So yeah, guys, please feel free. OneDrive, Dropbox, yeah, great. AWS, that's great. Firebase, okay. Nice to see that you are specifically moving towards cloud computing use cases. That's great to know. Yeah. Anyone else would like to bring something new use case that we don't know, that we don't use daily? Any particular specific use case of industry or something? Vimo, yeah, that's great. The live streaming models, yeah. Remote monitoring, yeah. The virtualization, the VDI, the VirtualBox, hypervisor, and all those things. Great. Thank you so much, guys, for such great interaction. And I hope you will continue same during the session. So let me tell you what it's actually like. What are the different models and what are the different architecture models, service models in cloud computing. So on the left-hand side, you can see the location. So we have, on the basis of location, we have three models, common three models, which is called as public cloud, private cloud, hybrid cloud. Okay. So public cloud is like the things are accessible to all of you. It's like internet, right? It's a google.com. It's a software deployed on the cloud server. And please, I was watching one of the funny video on YouTube, and there was one, I don't know, like he was something, or like he was a student or something, but he mentioned cloud computing is like if you have the raining going on, so you can't connect to the cloud server. And I was just so much laughing. So see, guys, cloud server is just a, I would say, a laptop or a server, or a server in a data center. That's all about cloud computing. Okay. So we have a public cloud, and moving to the private cloud, the services which are controlled exclusively to the user. If I say about Google Drive, so we have three options, right? In Google Drive, we have public access to a file. One second. Let me just switch off my video. I think like my bandwidth is consuming here. Yeah. One second. Yeah. So private cloud, like in the Google Drive, I was taking an example. So in Google Drive, we have the public cloud, which means you can access the files. Anyone can access the file with the link, right? That's a public cloud example. Private cloud, it's like you are extensively sharing those files to specific people, right? So it's a restricted access. Only the email IDs which you mentioned in the sharing capability of a file, it's a private cloud. Hybrid cloud, it's like the mix of both. So it's kind of organizational model where you can actually have the public cloud as well as private cloud integration. Okay, perfect. So these are the models of like I would say the types of cloud computing which we have in the market, and there are a lot of types coming up due to a lot of research going on into cloud domain. Coming to the services, so we have infrastructure as a service, platform as a service, software as a service. As many of you have mentioned, Google Drive, OneDrive, and Dropbox, and all these applications which are deployed over to a domain, it's all software as a services, because we are connecting to a software, a web application, to which we can access to a cloud server, to which we can access to a data, right, which is onto a server. Platform as a service, as many of you have mentioned in the chat window, AWS, Google Cloud, Microsoft Azure, and IBM Cloud, and all these platforms which gives you an access to host your application or to host your services, that are called as a platform as a service model. Infrastructure as a service, it's specifically to the physical layer. It's like if you know about OSI model of networking, so we have the physical layer. So on the physical layer, we have the storage, data center, load balancer, switches, routers, and all those things. That comes under infrastructure as a service. So if you request for a kind of instance or virtual machine on a Google Cloud, so it's like on the back end, someone is actually manually or automatically giving a space to you, right? And onto that, you are putting your application, and onto that, client are accessing those applications through that virtual infrastructure. And I am amazed to see in the research field of cloud what is going on these days from IEEE library, and people are like body as a service, sensor as a service, right? So there are a lot of different models what other companies are doing, and they are really I am really amazed to see how these guys are using the model of basic foundation of cloud. So what are the different pros and cons of cloud computing? So we will be discussing about that. So in the upcoming slides, I will be letting you know why edge computing. If we have already the cloud computing, why edge computing is being introduced now. So according to the advantages of cloud computing, we can see like we have the scaling and cost. It's very scalable. If you pay more money, you will get the more, like cloud is very scalable. If I say your Google Drive has 15 GB space by default, and if you want to increase the size of it, you just pay the money to Google and they will increase it, right? So that's very simple. It's a scalable model. Choice and agility, because it's like if I say it's my choice what I need to deploy onto the cloud, right? It's on your own end, and then encapsulated change management process. Now, in the services like AWS, Google Cloud, Microsoft Azure, or I would say WebEx, if we are facing some issue today in WebEx while hosting this webinar, the first desk to which we will approach is WebEx, the Cisco help desk, right? So Cisco guys will create a ticket for your issue, and they will go, and that's a automated change management process under the supply chain and the customer caring center and all the stuff. So it is also kind of one advantage that we can do a lot of automation on cloud. Next generation architecture, of course, like 5G is coming up, AI is going to deploy soon, and many of the services are already deployed on the cloud. So it's very like cutting edge technologies combined together, and you can go onto the cloud. So what are the different disadvantages of using like cloud? Why is it not kind of reliable model? Why we are not using cloud so much often? Why edge computing is there? So lock into service, security, lack of control and ownership, reliability. And I would say security is one of the advantage as well as the disadvantage of cloud computing. It depends upon you, how much firewall you are setting up, how much virtual, I would say, identity access management rules you are managing, and all the, I would say, access management policies you are deploying onto your application, onto your own cloud server. So security is kind of depending upon the application, what you are doing. And lack of control and ownership, obviously, like, like right now, if we use Windows, there's a lot of ransomware attacks we have so much reported, right? Take the example of Facebook. We have a lot of fake profiles these days. Why? Because we are already on a network node, and people are people are having the access, direct access to our servers. So cloud computing, if it is connected to internet, obviously it is connected to internet. That's one of the biggest security threat. Data breaching is one of the most, I would say, disadvantage of cloud computing where a lot of industries are consuming a lot of their expenses and money, right? Moving ahead, so many of you know about IoT, right? Internet of Things, connecting all the things, physical things together onto an internet banner, and we can go ahead. So what is actually that? What are the benefits of it, and what is actually that thing in Internet of Things? What we are meant by that thing in the definition of Internet of Things. So let's see, like, what are the different applications? What are the different sensing we can do through Internet of Things? The first one, device connection. So IoT devices, IoT connectivity is very feasible. Embedded intelligence, like putting AI on the Raspberry Pi or sensors or something, and we can get real-time data and we can put to the cloud, right? So then we can capture the data sensor on the real time, as I mentioned, and you can tag the storage. If I say, let's deploy our IoT infrastructure onto a very simple home automation model, okay? My application is now connected to the router of my home, but router is actually connected to the public cloud where we are getting the internet. Now, that web application, what it is doing, it is collecting the data of our electricity consumption. This was my first project on edge computing, which I did in third year of my bachelor's. So what I did, I had the Raspberry Pi. I connected to the each and appliance through the current sensor, and I got the power. What's the consumption going on in each and every appliance? I made a real-time database, and I put into the machine learning algorithm to predict the electricity bill. So that was my project in third year. So from where I got to know about IoT and edge computing in a very deep dive. Coming to the third part, it's like the communication. So communication is like how we are able to communicate. So if you know about the cloud computing infrastructure, we have the cloud layer, we have the application layer, right? And if you I would say zoom in the architecture, zoom in the layered architecture more, so you will get the OSI model combined with it, right? We have the physical layer, application layer, network layer, transport layer, and according to that, right? So in the IoT, we have to focus on the network, right? We have to focus on the latency. Hey, if you have a low speed, you can't do the sensing. You can't actually transmit the sensors, or you can't transmit the real-time data on the cloud, because network is one of the major problem in cloud and IoT, right? We are directly connecting to the cloud to do the prediction, to do the analysis and all the stuff. What's the other benefit of using IoT? That's data analytics. Yeah, obviously. Depending upon your size, depending upon your, I would say, capacity or the CPU uses of that edge node. I will be letting you know what is that edge node in the coming slide. So big data analytics you can perform offline. That's also one of the major part of, like, I would say, IoT. And it's very less usage because it comes to the topic of edge computing rather than to the cloud computing. Okay. Then coming to the data value. Now, if I say I want to get the weather API and I want to show onto my Arduino Uno board, okay, the user is asking from my chatbot, what's the weather right now, right? So I can just connect to the weather API from the Google and I can show the data onto my web application. That's kind of analysis to action API according to the user requirement. Last, what is very much, I would say, body as a body network. You all know about local area network, wide area network, and all those basic network models. We have one model which is specifically for smartwatch, smart sensors. That is called as body area network. So human body. So how you can collect the data of the human body. So that's all comes under the IoT, that sensing part, sensing analytics part. Okay, moving ahead. Okay, now I would like to know from all of you in the chat window, what do you think? What are the difference between edge computing and cloud computing? If you know about it, like, just let me know what are the difference between cloud and if we put cloud offline. What are the different advantages? Yeah, in the chat window, please go ahead. Nidhi, can you please confirm if my voice is clear?
Yes, Ramnik, your voice is clear.
Okay, fine. I thought need to like check in the between so that people can respond me back, and I will be like confused. Hey, I asked for the question, but people are not responding. So that's why I was checking up. Yeah. Guys, please feel free. What is the difference between IoT and the cloud? Let's say, yeah, IoT. Let's take an example of IoT. Let's see what's the difference between IoT and the cloud. Yeah, tell me, what are the advantages and what are the disadvantages? Why we are not using cloud? I have already told you the disadvantages of cloud computing. So can you please brief me about if you know about edge computing? Anyone, if you want to come on the audio, please feel free. You can unmute yourself. Cloud needs more time and bandwidth. Yeah, rightly said. It's a very one of the major, I would say, disadvantage of using cloud. Latency is one of the major parameter why edge was introduced. Thank you so much, Aryan. What about others? Any kind of disadvantage or any kind of limitation that you see using your daily products, daily digital applications, or what? Anything? Yeah. Anyone? It's fine. It can be right. It can be wrong. Answer is fine. I'm not giving any marks to you. It's fine. Close down the real-time application. Thank you so much. Yeah. Hey, Tavish, are you copying from Google? Please don't take the help of Sundar Pichai. We need your answers. Okay, cloud computing is more of data center virtualized position in regions. Edge computing is putting small portions of these larger data center close to the user. Thank you so much. That's great. Yeah, for example, edge location in the AWS. Perfect. Data security, yeah, that's one of the I would say disadvantage of using cloud. Wonderful. Thank you so much, guys. Let's move ahead and let's see what is actually edge computing. And you guys are on the spot. So edge computing is an IT deployment model which is specifically designed to put the application and the data as close as possible to the users or the things that need them. Right? If I mention, let's take an example of smartwatch. You have a smartwatch. It's connected to your smartphone using Bluetooth protocol or Wi-Fi protocol, right? So what you are doing, you are sharing the data near to the application, near to the, I would say, user layer, right? So you are putting all the application onto your smartphone, which is nearly connected to your user. So that's what the basic concept of edge computing. So what it actually means, it's like a distributed model, which is very like it's on the computing and the storage is very closer to the edge device. I will let you know what is edge device, where resources are needed and latency is a challenge. That's what you guys have mentioned in the chat window. Bandwidth. So latency is like the time period taken to download or upload a file. That's one of the biggest challenges in cloud computing. If I would like to share this recording with XCOM today after the session, the main thing is, how should I share? Shall I share through Drive? It will take a lot of time to me upload and to the XCOM to download, right? That's one of the latency issue. So let's see, like, where is the edge? Actually, we have two definitions in edge computing. We have edge computing, we have fog computing. So if you see the architecture in the bottom screen, you will find like we have the smart things, which are like smart cameras, traffic lights, or it can be kind of robotic hand, or it can be smart watch, or any other kind of things, which are actually collecting the data directly from the user, right? And the second layer comes to the IoT appliances. That's the main part where edge nodes come, edge devices come, right? So edge devices are nothing but the router, or I would say the Raspberry Pi, the microprocessor, controllers, and all those things, which are collecting the data on the real time. And then it comes with the connection of the routing, switching, and all the stuff. Routers we have, gateway we have on the third layer. And on the fourth layer, if you want to transmit that data, like if you have, if I say, let's take an example of state A, state B. So between the state A and B, we have, I would say, miles of distance. It's very impossible to connect the offline connection between them. So what we will use the telecommunication helping. We will use hand-overing techniques through cell tower. So from LAN, I will shift to WAN. So it will direct the, I would say, the data from the edge node to the cloud through the regional data center. Okay, there we get the cloud layer. So we have the physical layer, we have the application layer, we have the edge layer, and then we have the cloud layer. So that's pretty much, I would say, overview of architecture of edge computing. Okay, moving ahead. So why it is required, as I mentioned, and as many of you have mentioned in the chat window, bandwidth is one of the things, performance is one of the things. and we need a very low latency, so that's why we use edge. So yeah, it's very necessary to address the shortcoming in the cloud-based application and the services with respect to the performance and how we can regulate the requirements of the user. The trend towards digitalization, which is like coming up using 5G, and the industries are looking forward to the solution which can provide them a performance in a no second, right? It's very fueling the demand of edge computing in the market, and particularly the IoT application which are already in the place in the market. Yeah. Then IoT application often requires a lot of bandwidth. As I mentioned, like there are a lot of sensors you need to put, and those sensors are connected to the cloud for computation and all those stuff. But in edge computing, we do all the analytics, the big data analytics and all those stuff offline without internet. So there's no issue of latency, and we are having a very reliable performance while meeting the regulatory and policies and the compliance issues. Because if we are not connected to internet, that's one of the wonderful, I would say, model companies are looking for, right? It will decrease the security risk. It will decrease the latency, obviously. It will decrease the, I would say, headache of the user to upload and download the services or the application. So yeah, so let's see a use case. Let's see the different type of use cases in this diagram. So after applying edge computing, how we can see. Now, let me just bring out the pointer so that you can see the proper thing. Yeah, I hope my laser pointer is visible. Nidhi, can you confirm? Are you able to see the red mark?
Yes, it is visible.
Okay, perfect. Thank you. So if you see, we have the data center in the center model, okay? And let's say this is a cloud or data center of Reliance Jio, or maybe AWS, or maybe Google, okay? Let's stick to Google. Let's stick that it's a Google data center. And through this Google data center, we are able to access through mobile device. We are able to access smart buildings, smart traffic lights. Right now, we are able to imagine the cloud infrastructure, right? All our appliances and all other things are connected to internet directly to the data center. Now, in a state or in a city, in a smart city, if we say Pune is the second smart city of India. So if you see the applications in Pune Smart City website, so you will get to know why they are not directly connecting to the cloud. They are actually making edge gateway servers. Yeah, it's a server. It's like a replica of the data center, only to the data which is required for the processing of particular application. Okay, near to these traffic lights, we can put something. Near to the street lamp, we can put something like some data which is required. Like if I say, let's say 5 years of data. Okay, and data center is containing years of data. We don't need years of data, millions, or like I would say decades of data for us to process any data on the edge node. We just need 5 years or 10 years of data to store and to compute onto the edge node. So edge node is specifically near to the applications like connected rail system, connected cars, trucks, smart buildings, smart grid, traffic lights, and all those things, all the connected smart applications. So what is happening right now, if someone requests for a data or some prediction, this connected oil platform will send a request to edge a gateway server. And as I mentioned, we have a mini kind of data center, like 5 years of data storage onto the server itself, onto the edge node itself. And onto that edge node itself, we will compute all the things. We will compute the analytics, we will compute the machine learning prediction and all the stuff. And it's already done. We will just send back to the application, to the user. But in the cloud, what it was happening? Connected oil platform was sending a request directly to the cloud. It was increasing the latency. It was increasing the, I would say, business intelligence latency, like we were not able to predict very fast. It was not a real-time analytics. We need to wait for some seconds to get the output. So that was the disadvantage of using cloud. So that's how edge computing eliminates that. Okay, so before moving ahead to the use cases, I would like to know in the chat window if you guys understood about the concept of cloud computing and edge computing. Can I see yes, no in the chat window? One second, let me just, yeah. Okay, yeah. Can I see yes, no in the chat window if you are clear with the concept of cloud and the edge computing now? Yeah, okay. Great. Perfect, yeah. What about others? Ashish, Aryan, okay. Edge, no. Okay, I will explain it again. No worries, Om. What about others? Only 5 people are attentive. Okay, can you explain again? Kushbu, which part? Edge computing you are asking? Yeah, let me explain the edge part again then. Let me wait. Yeah, okay, perfect. Great, great. Nice to see you guys are on the presentation and you are on the same page with me. Let me explain about the edge computing again. I guess like this, the next diagram. Let me what should I do? Okay, let me go through this model. Okay, so if you see the architecture of this, like in the cloud computing, what we were doing, we were connecting to the cloud directly. If I say you, let's say smartwatch. Let's take the example of smartwatch. I want to compute the prediction. I want to compute the prediction. What is the right now predicted time, good time for me to do exercise, to do with fitness exercise, or what's the predicted time for me to go to park? Okay, because my smartwatch is collecting real-time data that at 6 o'clock or at 5 o'clock I need to walk, I need to go to park for my evening walk, right? So my smartwatch knows the data for months, for years onto my smartphone, right? It's an edge node. Smartwatch, take it as an edge node, okay? Now, if I want to store my data onto cloud, I need to take the help of cloud or Google Drive, OneDrive, Dropbox to store my all fitness data onto the cloud. And I want to share that data with my doctor so that he can diagnose if there's any problem in my body or any fitness problem is there, right? So how many layers we do have now? On the bottom, we have the application layer, right? We have the users. On the second layer, we have the smartwatch, all the appliances, right? Which are processing and which are collecting the real-time data. On the third layer, we have the cloud layer. So we have the 3 layers. So this is actually the basic model of edge computing. I hope Khushbu and Om, I hope I hope you understood the concept of edge computing now. Can I know yes, no, yes, no? Om and Khushbu, are you able to understand that now? Yeah, perfect. Thank you. Okay, moving ahead to the use cases now. Yeah, so what are the different use cases and what are the different trends right now in edge computing? What industries are working on? So that's a stats. That's a recent stat by statista.com, I guess. That's one of the websites from where I took this. So what they are saying right now, industries are working on industry at the edge, retail at the edge, healthcare at the edge, finance at the edge, and the education at the edge. Right? Can anyone please tell me the example of industry at the edge in the chat window? An example if you know. Now I told you the concept of edge computing, right? You know the concept of cloud as well. Can you please tell me any example of industry at the edge? Like any use case you have came through around yourself, maybe in the, I would say in your own company, or maybe like anything, tell me. Any kind of problem statement or the solution you have seen. I would love to learn from you. If you feel comfortable, you can come on the audio, it's fine. Okay, tell me about any particular use case. On the left hand side, you can see 5 categories which I have put. So out of these, have you actually experienced any kind of use case of this edge computing right now, like around you, in your society or in your community, in any hospital or nearby healthcare center? Because due to COVID, due to pandemic, and due to vaccination centers, we have came through a lot of innovation in the technology, how we are using IoT, how we are using edge computing. Can anyone please share their story or their use cases what they have encountered in their society? Please feel free. Anyone would like to share? Yeah. Argu Setu app as it uses Bluetooth. Yeah, kind of. Yeah. Thank you so much, Om. Yeah, it's kind of, I would say, healthcare at the edge, right? That comes under it. Yeah. So let me tell you, like I would say, our friends from outside India. So Argu Setu application is one of an application from Indian government for checking out if you are actually near around a COVID, I would say COVID around area, right? So Argu Setu app actually detects like if I say 5 houses are there in a society, and out of 5, 2 homes are having COVID symptoms. Okay, they are blocked. They are logged due to their COVID symptoms in their home. So using Bluetooth, Argu Setu app will actually detect to the nearby homes that yeah, you are actually your neighborhood has the COVID. I would say symptoms. So please don't go outside. It's kind of that kind of model. I hope our non-Indian citizens friends have got to know about it. Yeah. So Nidhi is saying like industrial application, condition monitoring in factories that work on real-time alert generation. Yeah, that's great. That's one of the wonderful example of industry at the edge. And that's how actually data centers also work. Like if I have some issue in one of the servers, I will get a pop-up into my data screen. These are the private network, right? We are not connected to the internet. These are the internal class A or private network. So we are only able to get the alert onto our side. Any other example? Retail at the edge. Can anyone please let me know? Okay. Real-time monitoring and data sharing with hospitals and doctors. Data storing at the edge. Great. Yeah. A lot of hospitals are using it. I came to know like Fortis Hospital is using it. Apollo Hospital, I went to them. I guess it's been so 5 years for me to went there. So I saw like they have established geo router in their hospital. So every floor was connected to each other. No one outside the hospital can access to that data. So it's a wonderful example of healthcare at the edge. Yeah. Any example of retail at the edge? I will also let you know one of the use case which I always used to share and I always get inspired from. It's a very common example and it's applicable globally. Many of you have came across to that example. Okay, let me tell you. So I was standing in the queue at a McDonald's, and I was waiting for my burger, and I was like, "Hey man, I am hungry. Please give my burger. Why are you not like giving me? It's a lot of like I am standing for a half an hour in the queue, and you are not providing me my burger. I am so much hungry." So what I encountered, they were using actually the I would say internal network application. So what it was, there were a lot of LCD, right? You have the LCD when you enter into a McDonald's so that you can see the menu and you can order it accordingly. And there's 1, 2, or 3 LCDs inside the kitchen. So one burger guy who is like packing up the dough and the other guy who's packing up the potatoes and all the stuff. So these guys are also having the access to that LCD. Yeah. So all these LCDs are connected to one network, right? And if I get into the McDonald's, if I connect to the Wi-Fi network to that McDonald's, I can get the stats of my burger preparation right away in my Android application. That's one of the wonderful examples which I was inspired from of IoT and edge computing. That comes under retail at edge. I hope every one of you have faced that problem. Hope you have seen that, right? Can I know yes, no? Like Burger King, McDonald's. Hope you have seen it, right? The Android application of McDonald's or the Pizza Bite or something, right? So we can actually track the real-time preparation of it. Where's my burger right now? How much estimated time is there? How much time I will get my burger on my table, right? So yeah, that's one of the wonderful retail example. And if you see the stats, like by 2025, we will have the hardware value to so much. Like I would say, right now the potential is $175 billion. The IoT, I would say the edge computing potential value, how it will be changed in the hardware industry, because edge computing is all about the edge node, edge layer, and the sensors and the IoT part. So $215 billion will be the actual potential value when 5G will come in the market in the upcoming years. So right now 2021 is going on. After 4 years, you will get to see edge computing a very lot. As Python came into the market and right away shown in the market, similarly, edge computing will be there with 5G integration. Yeah. So that's why it's a very trending domain where researchers are working. So we have the different categories shown here, and we have finance at the edge and the education at the edge. So education at the edge is one of the, I would say, wonderful example, because wonderful domain where researchers are working. I have seen Li-Fi examples. Wi-Fi is like you can transmit your data through the light, through actual light, the visible light, yeah, the tube light or the bulb light. So Wi-Fi is kind of that. Wi-Fi enabled bulb, if you have in your room, you can transfer the data. If that light is actually visible light is going on through your laptop, through your smartphone, you can connect to the data and internet. But I would say the advantage of it, not the disadvantage, it's a secure model because the person standing in another room won't able to access that data, right? Because that bulb is only, that visible light is only applicable to that room. There was one model, you can check it out on Google. I don't know the company name, I don't remember the company name, but what these guys have done, they have developed a edge computing model with Wi-Fi and 5G. They have deployed actually in Kenya or somewhere in Africa, African countries or somewhere, some of the schools. So they have deployed into a classroom where students can actually become like, can sit in a social distancing level due to COVID, and they can actually get the data from the Wi-Fi visible light, and that visible light data, like from one room to another room, the data can be transmitted using our edge node. Okay, so that's a wonderful example of education at the edge, how we can actually educate the people, right? Okay, moving ahead. So what's the difference between edge computing and fog computing? That's one of the misconceptions many researchers, and I was also confused when I came to know about these two terminology. So many people say edge computing and fog computing are the same, but according to me, what I have experienced, what I have researched so far, edge computing and fog computing has a very little difference. So as I mentioned, in the edge computing, we have the physical layer, the user layer, where we have all the, I would say, end devices and all the smartphones and all the laptops. Then we have the sensor layer, which is called as a edge layer, where we have all the Raspberry Pi and Arduino. Then the cloud layer, that's a model of edge computing. Now fog computing, we have near to the cloud, which is called as fog layer. Okay. Now, according to some of the researchers, what they do, what they actually mention, the data which we want for a cache type of thing, okay, that we store onto a fog layer, not to the cloud layer. So simply they are dividing the computation and the storage from the edge layer to two layers, which is called as edge layer and the fog layer, right? So we have the four layers now, the user layer, edge layer, fog layer, and the cloud layer. And you can see from the diagram, we have different sensing going on the lower level, mist layer, and then we have the storage devices, those are the local servers, and then we have the cloud layer, where we are actually storing the decades of data, right? Because right now in edge computing, we don't do computation on cloud. We do it locally, right? That's a major advantage of introducing edge computing. Okay, now coming to the part how we can actually integrate the cutting edge technologies what are right now in the market. How we can work on edge intelligence. Now I know like the PhD scholars who are on the call and who are researching on this topic, the networking field and the cloud computing field, I guess AI at the edge is one of the wonderful trend which will be coming soon. Once we have the 5G settled down in the market, and edge computing and AI, it will be the wonderful blast in the market. And how you can achieve it. So how it happens. Let's see. Onto the right side, on the right bottom side, you can see a lot of edge collaborations is going on. Okay. Now if I say any AI chatbot I need to make on my Raspberry Pi, I can do that. What are the different software required? You can use TensorFlow, you can use robotics operating system, you can use any kind of Intel, NVIDIA, or any other kind of graphics interface, right? And then you can actually compute and you can analyze these data onto the edge itself, and that can be transferred to cloud. So similarly, the things what we are doing right now, we are using AWS, we are using Azure to do the machine learning algorithm, the AI algorithm part onto the cloud. We are just shifting that all those things onto the TensorFlow or GPU pins, GPU boards or CPU boards and all those stuff, right? We have Tensor board also from Google. We have different boards by Raspberry Pi. We have different microcontrollers from Arduino. So Arduino organization. So these are the different use cases where you can actually explore the part of AI. What are the different use cases, popular use cases right now going on? The traffic detection. Now, we are using Google Maps. It's on the basis of cloud. But what it happens, if we can actually connect to the nearby traffic light, on the traffic light, we are connected with a smart camera. And before actually moving on to that road, I can get the intelligence data. Hey, you can't actually go into this road. It has a traffic going on due to some accident or due to some emergency situation. Just change it. And it's happening offline because you are actually connecting your connected car or your smartphone or the edge sensors which are onto your car, which is connected to the traffic light, right? And the smart camera is giving you the real-time analysis onto your Google Maps. Let's take an example of offline Google Maps. That's one of the wonderful intelligence transportation system where I'm also working in a working group under IEEE Standard Association initiated by Wipro. So autonomous driving is one of the wonderful examples. Tesla is working on it. Google is working on it. Amazon is working on it. A lot of companies are working on it through the introduction of electric vehicles. Then we have the location tracking. That's one of the, I would say, wonderful use case when you have kind of security issues or emergency, like we call 911 for some emergency situation outside in US. We call 1091 number for police department for helping for women safety and all the stuff. So how we can actually do it offline, right? Latency is one of the, I would say, major issue if we use cloud. So location tracking nodes can be established to nearby streets and we can actually connect with them due to some physical, I would say, safety issue, emergency is going on onto the highway or somewhere. So we can connect directly to the nearby center or nearby transportation department of that highway. Then we come with the AR and the VR. So augmented reality and the virtual reality is one of the trending field. Today I was attending one of the sessions from one of the scientists from TCS. So she was telling about VR and augmented reality, how we can actually use it. So I put this query in front of her, how we can actually use edge computing for AR and VR. So you mentioned is very, very beautifully, like the characters which we mention, which we deploy onto the applications of VR and AR, we can deploy onto Raspberry Pi. We can deploy onto our microprocessor and controllers. And that we can connect with the application offline, right? And the last one, which I already mentioned, the safety monitor, okay? Okay, now coming to, like, we came to know about edge computing, we came to know the use cases, common use cases which industries are working on, how to integrate edge computing and AI. The most trending field, 5G. Many of the people across the globe are working on it. They are talking about it. Right now, people are working on 6G now, right? So it actually, I would say, it's a coming trend, as I mentioned, 5G and edge computing. 5G has no, I would say, it's kind of gigabytes of speed per second, 100 gigabytes per second speed, bandwidth, and the edge computing has no latency issue, right? So if we combine both of these technologies together, we can have wonderful, I would say, use cases. We can do handovering in a very seconds. We can do, I would say, a lot of the hosting of the application offline. We can host and we can actually, you see the mission critical, I would say, use cases. Like if some on highway, some emergency situation happened or some medical issue happened, we can actually trigger the ambulance automatically using edge node connected to the 5G server, and the things will be so fast. So this is also one of the research scope of edge computing. Okay, now how to get started? What are the different platforms? What are the different, I would say, open source tools which you can explore on your own? One is from Microsoft Azure IoT Edge, Lambda at the Edge. That's one of the service provided by Amazon Web Services. Then we have the Dell Edge Gateways, VMware Pulse IoT Center provided by Dell. We have HP Edgeline. That's one of the service provided by HP. Then we have the Foghorn platform. That's an open platform. You can Google it. Then we have the Watson IoT platform service and the Cisco Edge routers. That's one of the, I would say, edge computing was coined in 2010. And then we came to know about this. Cisco is doing a lot of stuff, right? So Open Fog Consortium, Open Fog organization was the one who coined edge computing in the market in 2010. And then we came up, Amazon rolled out these services, Microsoft, Google, Watson, IBM, and Cisco. So you can explore these things, and a lot of applications are already there, right? And you can visit this website for getting to know more about what are the different edge computing vendors right now in the industry. Okay, what are the different tools, simulator tools, which you can use for your own research work or for your own learning? So Cisco Packet Tracer is one of the wonderful tools. You can sign up using your institutional ID or your Gmail ID, and you can download this tool for free on the student license. There we have different types of, I would say, routers, switches, IoT devices, and gateway and smart industrial application like renewable energy sources, right? We have wind energy, we have smart cameras and all the stuff. So you can just drag drop into the workspace and you can see the packet transmission. Similarly, like N3 network simulator. So we have another optimum network performance. We have Simulate, we have OMNet++, we have MATLAB, we have INET framework, and we have Melbourne. There's one professor, I don't remember the name, in Australia, like he has established this lab under one university. So his student has developed this software, this platform, Melbourne Cloud Lab. So you can explore it, you can Google it, and that's how you can actually get started in edge computing domain. So with that, I would like to end my session here, and I want to conclude. Thank you very much for so much your patience and interactivity during the session. Now I am open for the queries. Please feel free to interact with me. I will share my LinkedIn profile as well as my email ID in the chat window so that you can connect with me. Yeah, over to you, Nidhi.
Thank you, Ramnik. Thank you so much. It was indeed a very informative session for all of us. So I see participants, if you have any questions. So Ramnik has shared his LinkedIn profile and his email ID. You all can contact him. Okay, he has also shared his personal website. You should actually go and check it out. So there are no questions?
I guess like they are very clear about the concept or they were not listening to me.
There can be any of the two reasons. But I guess you have put it in very simple and lucid manner. It was actually very
Yeah,
nice.
I thought like,
And the biggest
yeah, I
confusion
thought
we
like,
have is, yeah. So the biggest confusion we have is the difference between fog and edge. So that is one thing that I have heard most of the time. People are actually not able to make out what is the difference, and everyone has their own theory that what is the difference. Some even say that it is same. So yes, that helps. That really helps.
yeah, so I was thinking for the same, like how I can put the content of the presentation in a very simplified form so that everyone can be on the same page. Maybe if you are already working on the edge computing, that's great. I would like to learn from you. You can connect me, and I would be really pleased to get connected with you for some of the research work you are already doing in this domain. And
Yeah.
if you are really a bachelor student, so I hope I cleared your query and you got to know about something new. So yeah, please feel free to share your feedback as well on the audio. If you are comfortable, please. I am thrilled to know about your feedback, how it was, how the presentation was. Have you got to learn something or not? Yeah, please feel free.
Yes, at least if you do not have any questions, at least give some feedback.
Yeah.
Rhea, you work on edge computing, right? Okay, so we have a question. Can you suggest any
Yeah.
books or videos or courses on any website to explore more? This is from Om.
That's a wonderful, I would say, question. Let me just pull up from Cisco. There's one Cisco Network Academy is there. So I believe they have a course on to edge computing. You guys can explore it, and let me just pull it off 1 second. Other than that, you can explore Udacity and other sources. I guess they do have some courses there. But let me just give you one link. There you go, so this is kind of one illustration or blog series provided by Cisco. It's a self-paced courses, so you can go through. Yeah. And regarding the Cisco Packet Tracer, let me just give you that link as well so that you can go through the course of it and you can learn about Cisco Packet Tracer more with the courses, self-paced courses which Cisco has provided. There you go. Yeah. Thank you so much, Om, for that wonderful question. Yeah. Is there any other question? Nidhi, you were telling someone like.
Yes, so I think Rhea is working on edge computing or fog computing. Rhea, can you hear me? I think no. So we have few people in our lab who are working on edge and fog computing. So what would you suggest if someone wants to implement it at lab scale for their research work, or maybe for their end-term
Yeah.
project for
Okay.
BTech
Yeah,
students if they are in their
that's
final BTech? Yeah.
yes, yes, yes. When I was in my final year, when I was doing my minor and major project in my bachelor's, so I came to know, like when I came to know about edge computing in my third year, I worked on this model. What I did, I developed the VMs in my Windows system. So my Windows system is the server right now, the main server, the cloud server, and I have 5 VMs into the virtual box. And all these virtual boxes are connected to my parent network of my Windows, my host network. So if you see from a point of view, I hosted one web application onto my cloud server, which is my Windows network, and all the VMs were connected to that particular server. So it was a kind of a private network, right? So if some node came from other, like outside, from the class C, from public network, and they used to connect to that private network, they weren't able to.
Right.
And I developed a Java software for that, that if someone wants to connect onto that particular private network, a pop-up will come, a alert system will come to the host server that, yeah, someone is trying to access your network. Do you want to approve it or do you want to decline it? So that was one of the models. What I can suggest right now, due to some of the, I would say, there's one trending field in edge computing where you can explore about DevOps architecture, Kubernetes and Jenkins and all those, I would say, automated deployment tools, because Docker is also one of the things. If you know about Docker containerization, if you deploy your application and containerize it onto the Docker hub, you can actually deploy it anywhere.
Right.
And I will give you a live example of it. Let me just CS50 Docker image, I guess. Yeah, there you go. Let me just give it to you guys. So yeah, I'm sharing a link. I hope you are aware about CS50 course by Harvard University. So David is the PhD professor there in Harvard who takes the classes for bachelor students. So he has established this CS50 IDE. So what it is actually, you need to deploy, you have to download one Docker image onto your system. And that's kind of a edge node kind of thing. It's a local development environment.
Okay.
Right? So that's one of the wonderful example where you can explore about edge computing and make some projects out of it. Yeah. So containerization is one of the trending fields on which you can build your application and containerize it for the security purposes.
Right. So currently we are also working on the same things. Me and Sashwati, we are working on something on Docker, using Docker.
That's great.
So yes, it is actually very useful, very useful and very efficient.
Yeah, I would like to collaborate. I would like to know what you guys are doing. I would like to learn about it, sure.
Sure. We'll have another discussion on that part.
Sure.
So any other feedback or question from the participants? I think we can conclude the session if there are no more questions or any feedback.
That's great. Yeah.
Would you like to?
Okay. Thank you so much, guys. Yeah. Nidhi, like, are we going to take our token of memory? Are we going to take a group pic as well?
Yes. So I would request all of the participants to please switch on your cameras so we can take a group photograph.
Yeah.
Let's see how many people will actually.
Yeah. I hope now they are comfortable for the 1 hour session. Now they will surely join us on the camera. Please feel free. Yeah. Yeah, Aryan, that's great. That's great lightning, I would say, technique. Go ahead. Just set up the curtain so that we can see your face.
Okay,
Thank you so much, Remelin. Thank you so much for joining from Philippines. Yeah. Perfect. We have a lot of people now.
Yes, we have lots of people.
Others, please feel free. Yeah, please feel free to join. It's fine. We know we all guys are working from home. We won't judge from your background. It's fine. We know a lot of things will be going on into your home. Yeah, it's fine. Yeah. Others? We have only 21 people. Why are you so much shy? No. If I ask the same question to a school student, they will come in a second on a camera. And you are like PhD scholars and BTech students. Great. Yeah, perfect. Nidhi, just give us a green signal. Do we want to make some pause or something? V shape or victory of this session or something?
Anything? Would you like to have a victory with edge
Yeah,
and
that would be
cloud
nice. Yeah.
computing?
We can make R, right?
Yeah.
Rocking
What?
Oh,
R?
how you can make R?
How
I
do
don't
we
know
make
how
R?
to make R.
Maybe something like this and this.
Oh.
V is fine. Finally, we are
That's a
over
more.
with. We have some knowledge about
Yeah.
edge computing, including the opinions from the industry expert. So yes, we can take the picture.
Yeah. Yeah. Great. Can we make a V and a big smile on your face? Let's take it. Nidhi, are you taking it or shall I?
You can also take it. I'm also taking it.
Okay. 1 second. Let me go ahead from my side. Okay.
Okay.
There you go. 1, 2, and
Two,
3.
three.
Perfect. Thank you so much, guys. Nidhi, have you captured?
Yeah.
It's fine.
Thank
Yeah.
you.
Okay. Great.
So
Thank you
much.
so much, everyone, for joining us in this evening, Saturday evening. And I hope you got a lot of insights and looking forward to connect with all of you on LinkedIn. Thank you, guys. Take care. Stay home. Stay safe. Bye-bye.
Thank you, Ramnik. Thank you all. Bye bye.